Hi everyone, in this video we're going to go through the solutions to the bivariate test with transformations. So as a whole, done much better than the previous bivariate data test, which is great to see. You should be very proud of the progress that you've made from one test to the next. Going with the introduction of transformations, just making sure we go through that and understand how to do it, but also some errors that keep popping up. So just make sure that your bound reference is up to date and that you're also referring to it on a regular basis. You get used to using it and familiar with how questions are asked and what to look for, blah, blah, blah. All right, so very first one, we've got to draw a least squares regression line. Some students may miss this question, didn't answer it. I would say it was missed. So just make sure if you see a scatter plot, it usually asks you to draw a least squares regression line. Now, when you do that, always go to the end points. So for this one here, we are starting at 0, but remember they don't all start at 0. So just take note of what we're starting at and what we're ending at. So for this one, we're starting at 0. So we want to know the corresponding y value when we substitute 0 into our x variable. So you can see there 0, 131, so that's plotted. And then our other endpoint, so we're going to put in 30 and we get 50.6. Now, obviously when we draw that line, we want to have it look like the least squares regression line. So you should have points roughly each side of it because it's a line of best fit. Just making sure when you sketch your points, I always say to choose the 2 end points because it's going to make it more accurate. But when we have a look at another question soon, you'll see that we can't choose those 2 end points. So we just go in and choose 2 other points. You can choose whatever points you like, x values you like, anywhere along here. But the further apart, the more accurate it's going to be. And when someone marks your graph, they do look at the 2 end points. All right, so they're key features that we do look for. All right, so using the equation, so this was done quite well. You don't have to convert this 35%. It is already as a percentage. So you're just substituting 35 into there and getting 37.2. Also, just question your answer. So if you converted this percentage to a decimal by dividing it by 100, your answer probably wouldn't make sense. So just making sure when you get an answer, just go, oh, does that make sense? Does that look like it is what it should be? And when you think 35 is down here, so an answer of 37.2 does make sense. All right, part C, the coefficient of determination for this one is 0.8081, and we've got to interpret it. So some students rounded this to 1 decimal place. Nowhere did it say to round it. So that's automatically wrong. You can't round a question unless it asks you. Now I know later on there were some questions I didn't tell you to round. And therefore I should have. So that was my error. But here, yeah, you can't round unless it told you to round. So if you wrote 80.8% on an exam, you would actually get this question wrong. So make sure you're writing all decimal places. So 80.81% of the variation in rainfall can be explained by the variation in percentage clear days. So straightforward bound reference question. All right, it was disappointing to see students get this one wrong because there was a question on your bivariate test. So your R value is either negative or positive. All right, we can see it's negative. First of all, we've got a negative gradient, but we can also see our scatter plot is going down. So your R value has to be negative. So not only do you take the square root and get 0.899, but you have to chuck that negative sign in front of it. Otherwise, well, 2 marks is very generous. Now you'd probably only get, that'll be a 1 mark question. It's either right or wrong. Here it does say Pearson's product moment correlation coefficient. That's just the fancy name for R. We just see it as the correlation coefficient. All right, moving on to question 2. So we've got the mean surface temperature and mean duration of warm spell in days in Australia for 13 years, blah, blah, blah. Now, sometimes you don't even have to understand the context, especially when they give you a scatter plot, because we can see on the x-axis is our explanatory variable. If we weren't given that, you would have to think a bit more about your variables and which one's your explanatory and which one's your response. Oh, I don't want to do that. Okay. So anyway, we had to put an extra point on, so that very last point we had to put on our scatter plot. You had this printed for you. You should have counted. So 53.1, 50, 51, 52, 53. Some of you did not have that cross in the right spot. So it either had to be at 53 or between 53 and 54 was also accepted. But if you were below 53, clearly wrong. All right. So just making sure you do that correctly. All right. But that was done quite well. All right, part B was done really well, which was good to see. Some of you got your variables around the wrong way. All right, here's our scatter plot. Mean surface temperature is our X. Mean duration of warm spell is our Y. All right, so just being careful with your variables, making sure you get them around the right way. And it was to 1 decimal place. So this exam was probably previous to doing significant figures. That's why it's not asking for significant figures, but we do now see these types of questions with significant figures. All right, then we had to plot the least squares regression line. So we had to go back here and plot that line. So remember I said do your 2 endpoints. Now when we do that, we actually get a value that's not on our grid, which is very annoying. So when it's off your grid, just go to the next value. So you can see I've substituted in 13.2 here, and I get 19.06. So just plotting that point, you can see my point plotted there. All right, at 19. Probably should be a little bit higher. But in an exam, they're pretty forgiving. I'm just looking at that, probably should be a little bit higher. And then if I was to substitute in 14, I'm also off the graph up here. So this one was probably, well, definitely not done well by the class, but also by the state when they did this exam. So you just go and substitute in 13.8. And what was that corresponding? 55.24. So you can see I've got a little dot there. So when I was checking your answers, most of you put it through this point that you added in. You actually got this value down the bottom. I don't know whether you looked for your, well, it's still not an x-intercept, but yeah, it was pretty much in the right spot there, but they're not up here. So when marking this, they would definitely look for key points. And I would say they're looking for points at 13.2 and 13.8. So just taking care with that. All right, so that was a pretty hard one to draw. All right, and then we've got a residual plot. So you don't have to complicate your answer for this, and we've seen quite a few of these already. Something similar, like the residual values are randomly scattered. And I probably should add either side of the x-axis. I don't know, probably, or above and below the x-axis. But you could also say there's no clear pattern. I think because there's only one line, we don't have to go too far. The residual values are randomly scattered. All right, and that's in your, well, it was given to you, so in your notes, so should be in your bound book. All right, so when a residual plot looks like that, what does it mean? All right, how do we interpret that? All right, this question D is sometimes it doesn't explicitly say what is the R squared value. It just says write down the percentage of variation. And I think we had a question like this on the last test. So percentage of variation is just your R squared value. Now it can be either explained or not explained. So on the previous test, we had one example of was not explained. So is explained is 83%. And then if you wanted to do not explained, then it's just the taking away that from 100, so 17%. But don't do both, all right? You don't give more information in a question than is required, because if you start doing that, then the person assessing it is like, well, what's your actual answer? Even though what you've written is correct, but how do I know you actually know the answer to this question? So just making sure that you just give the answer, all right? And we don't have to put things in sentences. So you can see with E, it's asking for strength, direction, and form. You just need to put those three words: strong, positive, linear. They don't even have to be in the same order that it is in the question. However, what students did wrong with this is they looked at the scatter plot. The residual plot, which is a scatter plot, but they looked at the residual plot and interpreted for that. But the residual plot is a plot of the residuals for this graph here. When you did your equation in part B, or question B, part 1, you would have got your R value, and the R value, and also for D, all right? So your R value was really high. I think it was like 0.9 something. So interpreting your R is strong, positive, and linear, all right? So the linear part comes from either looking at this, clearly linear, or your residual plot also tells us it's linear, all right? Remember, when it's randomly scattered, it is linear, right? This graph, this scatter plot is linear. Or the association is linear, I should say. Obviously, it's not clearly 100% linear. All right, and then we did some transformation questions. So these are from past exam questions, but I just, created my own question here. So we're looking at wind speed at 9 a.m. versus wind speed at 3 p.m. And we can see it's curved. It also tells us in the question that it's non-linear, which is awesome. Now, in an exam, they usually tell you which transformation to do. I wanted you to use your circle of transformations to decide, which was done really well. You didn't have to write the equation, but I've written them there. So unless it says to write the equation, you don't need to write it down. You can just write your R squared value, but obviously if it asks for the equation, you need to give the equation. So I've just written them there just so I knew what they were. And we also had to decide which one was best. So remember, the higher the R squared value, the better the model is going to be. So log X, clearly the highest. Now you could write these as percentages as well. Probably should have done that. So let me just go on and do that. So this is 83.58. And you'll notice my R squared value, I've done to 4 decimal places. That's because we always show R squared as a percentage, all right? It's a percentage in variation. So you could have had it in blue or in pink. I would have accepted either, but technically we do the pink. And 4 significant figures, that was done quite well. All right, then we've got the equation, also done quite well. Although some students got these numbers wrong, I don't know. If you're having trouble, if you got this wrong and you're still having trouble with transformations, there is a video on transformations, but I strongly encourage you to get some one-on-one help. So either coming to Hour of Power or getting help in the library, just making sure that you know how to do transformations. It is not overly difficult. It just looks more difficult than what it is. And what we're doing with transformations, it just means we're taking a non-linear scatter plot and kind of making it linear. All right, but I strongly encourage you to watch the video on that if you haven't already done so, and then also getting some help if you had trouble with the transformation questions. All right, moving on to part C. So this part here was not done overly well. Some students just did times 14. We're using this equation in part B. It says here, use the equation in part B. Hello, here it is. All right, you've got to do log of 14. So in your calculator, let me just show you, just with one of them. So 0.287, you don't need the 0, but we'll put it there, plus 8.268 times, now your little log is this one here, log 10, and then we put in 14. All right, I know I didn't say how many, what to round it to, so I just did to 2 decimal places. I kind of accepted 1, 2, 3. Someone I think did like 8. I don't know. As long as you gave an answer which indicated that it was correct, just make sure you show that substitution in your equation as well, so we know where it's come from. I know I didn't do it for part 2, but yeah, same thing. Instead of the 14, we've got 22. So you can just go back up here. I always think highlighting and dragging down and then changing the number is better. All right, which of the above predictions is more reliable? These sorts of questions I think are so easy, because even if you didn't know, it's 50-50. But you've got to explain why. And basically, when we're talking about reliability of a prediction, we're talking about the about interpolation, whether it's inside the data set or extrapolation. So outside of the data set. So outside of the data set is not as reliable. Inside the data set is. And let me use an example that you can actually think of. So we're all sitting inside the classroom, right? The heights may range from, let's say, 150 centimeters, maybe up to 180 centimeters. And we've plotted the height against weight. All right, so we wanted to predict someone's weight based on their height. So let's say we said, all right, what's 170? So we chuck it into the equation and get someone's weight. I don't know, let's say they're 70 kilos. Now, if I said, all right, here's someone who is 210 centimeters, and we chuck it into the formula. First of all, it's an outlier, all right? Who's 100? Well, you know, some people are 210 centimeters, but it is an outlier. It's outside of the data set. It is an extreme value. It is going to be our model is going to be highly unreliable in predicting the weight of that person. It might make them heavier or lighter than what they probably are. So inside the data set, if we got anyone between 160 and 180 centimeters, then, you know, it's quite reliable. If we had someone who was 130 centimeters, so very short, you know, our model might say they're 20 kilos, and it's like, well, that's not much. So that's what it means by reliability. Once you go outside the data set, it's not really that reliable. So that's an example of extrapolation. So 22 was outside the data set, 14 inside the data set. And what I mean by that, if we have a look here, so it's always for your X value, 14 inside the data set, 22 just outside the data set. So it's still probably reliable. If I had a wind speed of 30, very high. All right, so quite unreliable. All right, and then part 4, we're kind of flipping it. So we're solving for X this time as opposed to Y. So I saw quite a few students do residuals with this, and I kind of understand why, because it says predicted and actual. So all that means is when you're not, so it's not a residual question. So when your wind speed at 3 p.m. is 10, so that's what we're going to put here. All right, wind speed 3 p.m. So it's 10 equals blah, 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 log of wind speed at 9 a.m. I got a bit lazy and just wrote 9 a.m. All right, so then we solve it and we get 14.95. A few of you got that, but you just go solve. All right, if you don't have to solve anything by hand, we just go solve 10, and don't use calculator syntax on your SAC or on your exam. All right, it's highly frowned upon, and in an exam, if it was like a show that question, they just would not allow it. All right, so you can see what I did there, the log X. So we're solving for X this time. We're solving for the explanatory variable 9 a.m. All right, let's move on to the next one. So another nonlinear graph, chose a different looking one, so we had to do different types of transformations. Here I've written equations again, but we're really only focusing on the R squared value. Again, I didn't write them as percentages, so let's just plug that in. Just be careful with your rounding as well. I saw if you round the 43.99 to 44, it says 4 significant figures, so you just don't go ahead and round it to what suits you. You've got to stick to what it says because you'll get it wrong. All right, they'll mark on an exam, they'll mark you wrong. All right, and you don't want to also make the mistake on the SAC. All right, part B, writing the equation. So this was done quite well, just making sure you use your variables. So homework instead of Y, and it's 1 over TV or television hours. Part C, we're substituting in for 12, so 1 over 12, so television hours is 12, and then 2 hours there. And then which one's more reliable? So we want the one inside the data set. So if we look at 12 and 2, so 12 is within the data set, 2 is outside the data set. Our lowest value is, I think, 4 or 3. Our lowest value is 3, so 2 is just outside the data set, but I wanted to choose a value that was outside the data set. I did see one student that said that was an extremely high number of hours to study. But I don't know, if you're only watching television for 2 hours a week, you've got a lot of time to study, I guess. And then part 4, again, we're solving for TV. There was an error. I did have homework twice. So, yeah, it should have said television here. A few of you knew that and answered it correctly, which was good, but I didn't include that mark in your overall test result. So you'll notice I did it out of 32, not out of 33, because I didn't include that one. But yeah, so similar to the previous one, we're solving for the X variable. So just make sure you go solve. So I'll just show you quickly. So solve, oh, I don't like that, that's flashing at me. 15 equals 5.123 plus 102.9. Got a bit distracted with that flashing. Let me just make sure that's right. All right, times, and then you can just go 1 over X. All right, that's all you need to do, comma X. Just make sure when you write your answer, you don't write X equals, it's TV equals. All right, because you'll get it wrong. It's not X, it's TV, television hours. All right, and then the bonus question, which most of you got up to, which was great to see. So you had to draw the scatter plot. This was not a difficult one to do compared to the previous two. So choosing the two ends, 0 and 20. So having 13 and then 26.4. And then interpreting the vertical intercept. So again, this is in your bound reference. So basically, your y-intercept is when x equals 0. So when your minimum temperature is 0 degrees Celsius, your maximum temperature is predicted to be 13 degrees Celsius. That's all that means. Right, should be in your bound book. Easy to just substitute in the words. All right, and then interpreting the slope, again, same thing, just changing your words. This one wasn't as hard as previous ones because they're both, well, your x variable is always increasing, but this one's increasing. It's sometimes harder when it's decreasing because students write decreasing and then a negative. Just make sure you don't make that mistake. And then the last one did say to the nearest percentage, so 40%. But well done, guys. Making sure that you do have your bound book up to date. All right, you can't do these questions without an up-to-date bound reference. And you can see these are all past exam questions except for the transformations one. But yeah, understanding transformations. There were a few of you who got it completely wrong, and it's just a vital area of your SAC that you do need to know how to do. All right.